All right, today we're going to be talking about curves of best fit. We will be able to analyze data to determine the equation of the curve of best fit, and we will be able to use the curve of best fit to make predictions and solve real-world problems. So situation 1, Jane is a researcher. Sorry about that. Jane is a researcher at the Department of Agriculture. She has noticed that farmers have very different crop yields across the country depending on the climate. The graph shown is her data collection. So, what type of trend does this show? Well, because it makes a U shape, we know that it's quadratic. And because it's pointing down, we know it's negative. So which would be the best equation to represent this data? Well, we know it needs to start with a negative, so it has to be A or D. And which one of those is quadratic? Well, D is quadratic because it has the squared, so D would be the best answer. At approximately what temperature did farmers yield the most crops? Well, we want to look at the peak. The peak is up here, so if we go down, somewhere between 15 and 20 degrees, so let's say about the most is at 18 degrees Celsius. And the least, well, there's two places. We have here and we have here. So I would say about 9 degrees Celsius and 29 degrees Celsius. Curve of best fit is a curve used to model the trend. Trend just means pattern of data. So remember, line of best fit, it looks like a line, and a curve of best fit is going to make a U shape. Situation number 2. The table shows students' test scores and how many hours per night they stay awake studying. The data shows a quadratic regression. What is an equation that most closely represents a curve of best fit for the data? So we're going to go to Desmos. We're going to click plus, and we're going to add a table. And then I'm going to put my hours of studying each night in X1. And then in Y1, I'm going to put the test scores. And we can't see our dots on this graph, but if you want to see them, you can click the magnifying glass in the corner. And there's our data. So it kind of looks quadratic. It goes up and then starts to come back down. To get the equation, we're going to click on line 2 and put in our equation. Y1 is approximately AX1 squared plus BX1 plus C. And these A, B, and C values are what we need to write our equation. And we're going to use those and we're going to round to 2 decimal places. So our equation will start with y equals -5.04, because the 9 would make the 3 round up, x squared plus 34.98x plus 26.29. Part B, using this trend, what could be the test score for a student who spends 2 hours studying per night? So 2 is in hours, hours was our x, we're going to plug 2 in where the x was. So -5.04 times 2 squared plus 34.98 times 2 plus 26.29. You can use a regular calculator for that. I'm going to use the calculator on Desmos just because it's what I have up. So negative 5.04 times 2 squared plus 34.98 times 2 plus 26.29, and I get 76.09. So y equals 76.09, right? That's all for today. Fill in your summary, and I'll see you in class.